chapter 4, we are going to start using our periodic tables. So, how do we tell atoms apart? Elements are different because they have different numbers of protons. The element's atomic number is the number of protons in the nucleus of an atom of that element. The atomic number is the smaller whole number on the periodic table, and sometimes they can be in different spots, but you just look for that whole number inside of the box for the element. In a neutral atom, the number of protons equals the number of electrons. So, for example, what's the atomic number of gold? Gold is located in the center of the periodic table near the bottom of that big block on top, and its symbol is AU, which we should know that, coming up soon. So AU symbol, and that has an atomic number of 79. Bromine is our next one. Bromine is located on the right side of the periodic table, in the second row from the right, middle way down. Symbol is Br, and it has an atomic number of 35. And last but not least, cesium. Symbol is Cs. That's all the way on the left side near the bottom corner, and that atomic number is 55. Notice how the atomic number is that whole number inside the box. The mass number is also located in your box on the periodic table. Like Rutherford hypothesized, most of the mass in an atom is concentrated in the nucleus because the protons and neutrons have the most mass. They weigh the same. The total number of protons and neutrons in an atom is what we call the mass number. The mass number is the decimal number in your periodic table, in the box on the periodic table. And you need to make sure that you round it. So here, make sure you put a note that you need to round. Mass number means that you rounded the number. We use decimal, but we're going to round it to a whole because we can't have half of a proton or half of a neutron. To figure out the neutrons are not given in the box. You take the mass number rounded to whole minus the atomic number in order to find that. So with these two elements, F for fluorine and Hg for mercury, let's figure out the numbers of the protons, electrons, and neutrons. So I'm going to line up. P plus stands for protons, E negative stands for electrons, and N0 stands for neutrons. Okay, so let's do fluorine first. Protons, we have two numbers in our boxes. We have the 9 and we have the 18.999. The 9 is the smaller number in the box, and it is rounded to whole, so that is our atomic number. So that tells us that we have 9 protons. Well, because I didn't tell you otherwise, the electrons are also going to be equal to 9. So we got 2 out of our 3. The third one is where we have to do our subtraction. So we need to take the mass number minus the atomic number. Well, if this is the atomic number, 9, then the 18.999 or 18.998 is the mass number. Okay, so to figure out our neutrons, we need to round this to the closest whole number and then subtract 9 from it. So 18.998 would round to 19, right? So we'll take 19 minus 9 gives us a total of 10 neutrons. All right, let's try this again for mercury. We are going to figure out protons, electrons, and neutrons. Kind of looks like pen, doesn't it? Protons, we use the atomic number. It's in the same spot as the other box. So that is bottom, the 80 is our smaller and it's whole. So that'll be our proton number, 80 protons. Well, it's neutral because I didn't tell you otherwise, so that will be 80 electrons as well. And then last but not least, neutrons, we have to take the mass number, round it to, if it's 200.59, that 5 is going to make us round to 201. So we'll have 201 minus 80 is equal to 121. And that's all you have to do. So on the assignment, it's called Using the Periodic Table assignment. We are going to be figuring out protons, electrons, neutrons, also practicing our symbols and identifying mass number and atomic number. And that worksheet, you're going to have a table like that, just on almost the same way on the Chapter 4 test. So let's get started.